Hi, everyone. So here, going to show you how to do an independent samples t-test in SPSS to follow up on the earlier video. I showed you how to do dependent samples t-test, the two different ways. I don't have a video for the one sample t-test, by the way. You kind of see that procedure in the dependent samples t-test video, because that's another way to do a one sample t-test is do it on the sample of difference scores. But just to kind of flag that the original one sample t-test procedure, I think I just told you how to do on the slides because it's not really anything crazy or new there that you had to do. For this one, I am going to make a video because there are a couple new things that you haven't had to do in SPSS yet for this to appropriately do the independent samples t-test. So I'm just going to work from the same example I was using on the slides here. So we have this hypothetical study where we are comparing, like we always are for an independent samples t-test, two different groups of people. And in this case, the difference between these two groups is what? So we are randomly assigning 4 students each to either take notes by hand or take notes on their laptop. And then we want to see if that has any effect on their final grade in the course. So here's the hypothetical data that I gave you for this. And I'm going to show you this basically from scratch. So I'm actually going to enter in the data here quickly. So the first thing that might be a little bit counterintuitive is it might kind of feel like the right way for you to set this up would be to do 2 separate columns, right? So you have like one column is going to be these scores, and then another column would be these scores. That's actually not the case for an independent samples t-test. You want to remember, usually what we're trying to do in SPSS is make it so that each column reflects a variable. So each column reflects one variable. In this case, we are measuring the exact same thing, right? This is our dependent variable is measured for the exact same way for everybody in our data set. And that variable is, in this case, their final grade in the course, their percentage grade in this course. So we actually want to just put all of these different scores into one column here. We're going to start by just creating that variable. We can go into variable view, and then we can just call that grade. Okay, we don't have to have any decimal places for this because it's just a whole number, an integer. And then we can let SPSS know that this is going to be a scale numeric variable, essentially. It's either an interval or ratio variable is what you're telling SPSS when you're selecting scale. And then we can just go ahead and enter our data in like that. So we have 81, 94, 77, 85, and then jumping over here, 91, 83, 74, and 65. Okay, so we have all the scores on our dependent variable. Now, obviously, what's missing here, we have to have some way of telling SPSS who is in which group, right? We have 2 different groups. Right now, SPSS doesn't know which of these people are in which of those 2 groups. 2 groups being, again, the handwritten notes group or the laptop notes group. So how we're going to do that is, well, that's actually another variable that we need to enter into SPSS. But now it's just not a numeric variable. We talked about these way back at the start of the class. It's a nominal or categorical variable. So what we're saying is this is a variable that tracks essentially which person is in which group or in which experimental condition in this case, as opposed to some kind of numeric variable like this one, the grade. Okay, so different ways of doing this. You could start by just assigning values here to distinguish between the 2 groups. So I could just type in, okay, all of those people are in one group, so we'll just assign 1 to all of them. And then these people are in a different group, assign a different number. Then we're going to need to tell SPSS some additional things about what this variable is. So we'll hop back over to variable view. So for starters, we could give it a more useful name. In this case, it would be what group or condition people are in. We can tell SPSS over here, this is a nominal variable. So nominal, by the way, just a different name for a categorical variable. Different levels, different scores on this variable essentially reflect different categories of people. And then the last thing that you haven't done in SPSS yet is use this little values selector, values column here. And so for this, when you have a nominal variable, what you can do now is, okay, you see this little So if you just click here, nothing will happen on the none part. You need to click on this right here. You see these little ellipsis right here. So click on that, and then the value labels window will pop up, and now this will allow you to add value labels, basically assigning sort of the category names, the category labels to the different numbers that you actually type in your data set. So we just typed in 1 for the handwritten group and then 2 for the laptop group. So now just click on this plus sign here. And we just have to tell SPSS exactly that. So a 1 that we just typed in means they are in the handwritten group, and then hit the plus sign again to add a second one. 2 means they are in the laptop group. Hit OK. And then now if we go back to the data view, you'll actually see those labels. So instead of 1 and 2, because we just entered in the value labels, now we can see this as handwritten and laptop. That's probably going to be the more useful view for you typically if you're analyzing this data, just so you can kind of remember which condition is which. But if you did want to see the numbers again, you see this little button at the top here. This will allow you to switch back and forth between the two views. Okay, so here, now we can get it back to numbers again. You hit this and you can see the value labels again. So this just kind of toggles back and forth between those two options. Okay, so now we have everything set up the way it needs to be in SPSS for us to be able to do our independent samples t-test. Let's go ahead and run that test now. So analyze, compare means and proportions. This is kind of where we've been working this whole week because all of our t-tests are right here, right? One sample t-test, independent samples t-test, and paired samples t-test. So now we want our independent samples t-test here. We have grouping variable and test variable. Basically, in this case, that's going to be our IV, the independent variable, and our dependent variable here. So we'll go ahead and enter grade. That's the variable that we're saying could depend upon the experimental condition that people are in. So whether they did laptop or handwritten notes. Okay, then you're always going to have to do this. For the grouping variable, they want you to define the groups. So click on this. And then in this case, we don't actually have to change anything because this is correct right now, the way it's set up. Okay, group 1 and group 2, and then we're just telling them what are the values that we had used for those two groups. Okay, so it's not letting me go back to that view now, but you remember this was 1 here and 2 here. So this is where you're just putting in those values essentially. We want to compare group 1 to group 2. And then here as well, I will just note, like the dependent samples t-test, where I kind of emphasized that the order can matter. So because we assigned handwritten as group 1 here and laptop group as group 2, basically that determines the way that the calculation is going to happen, the order of the calculation. In terms of, we can put it in terms of maybe like the t-score is the easiest way to think about it. In the numerator for your t-score for this test, you have M1 minus M2. So that is going to correspond to this, right? If whatever I assign to group 1 here is going to be the M1, and then whatever I assign to group 2 it's going to be subtracting that from group 1. So if it makes more sense conceptually, whatever, depending on your research question, your hypothesis, if you actually want it in the other direction, right? In this case, maybe I want handwritten to be M2 and then laptop to be M1. That's how I want it to calculate that difference in the numerator. You can do that. You can just do that here. Okay, but for us, this makes sense in this case because I think our hypothesis was a one-tailed upper test. We're saying handwritten grade is going to be significantly higher than the laptop grade. So this is fine for us. Okay, M1 handwritten group versus minus M2, the laptop group. Continue to get our effect size. You don't have to do anything because this box is already checked. Estimate effect sizes, and you're ready to go. So similar descriptive statistics you'll get for pretty much any procedure in SPSS. You get sample size for each group, mean, standard deviation, standard error for each group. And then the main table we're interested in is this one. So independent samples t-test. We can look first for our t-score, 0.89, although with rounding, so we're going to round that up to 0.90 in this case. And your p-value is a 0.202 for a one-sided test. So there's the two main things you would usually care about if you're just testing for statistical significance here. We can go back to our slides, make sure that that lines up with what we found by the hand calculations. See where we calculated that. Okay, we had calculated our t-score by hand as 0.90, exactly what we found. And we know because of the p-value, that is non-significant. So we have non-significant test again, fail to reject the null hypothesis. We can't say that we have evidence that handwritten notes led to higher grades in the course than laptop notes did. And then last piece here would be, we get our effect size again, Cohen's d effect size. The point estimate, we get 0.63. And there again, we can double check with our by hand calculations we did on the slides. Here's that calculation for D for an independent samples t-test M1 minus M2 over your S pooled. By hand, we got 0.63. Same result. And I think I also noted this on the slides, but this is one of those interesting cases where you see the conclusion of the significance test, the NHST stuff, differs a little bit from what we see from the effect size, right? So that's kind of what would be considered like a medium to large effect size according to Cohen's standard, 0.63. And you can see that at the level of the means as well, right? We see like there is some difference there. It's not that the two means are very, very close together. There seems to be some difference in grades, not a negligible difference, right? A final grade in a course of 84 as opposed to 78, like 6 percentage points. That's kind of a big difference. So why are we not finding a statistically significant result here is the question. And hopefully the answer for that occurs to you if you remember what goes into p-values other than the effect size. So the p-value is based on two things. It's based on effect size. It's also based on sample size though. So larger sample sizes, you'll tend to see smaller p-values. It's easier to reject the null. What is our sample size here? Total of 8, 4 people per group. So pretty tiny sample sizes. Basically, even if you have kind of a larger effect, it's going to be hard to find anything that's statistically significant with such a small sample size. So that's why we end up with this result in this case. If we had a larger sample and we found the exact same effect size, the same means, the same standard deviations, just with a larger sample, this would probably end up being statistically significant. It's just not in this case because it is such a small sample. Okay, so there you go, independent samples t-test in SPSS.